In previous session, I spoke about collision domain. I showed you what have to place means, what will do place means, and I talked about sending and receiving at the same time or in different times. And now what I'm going to do is to broaden the concept a little bit. I'm going to speak about broadcast domain. A broadcast domain is the amount of space that can hear you shout. As a matter of fact, you can, of course, restrict this circle, limit the amount of space that can hear you, and this is very good. We are going to do this using VLANs in the next sessions. But here, what I'm going to do is to show you that when all the devices are in the same virtual LAN, which we are going to talk about this in detail later, almost everybody can hear everybody, which is going to clutter network a little bit. What I mean is, when everybody starts shouting, what happens to the network? The network is going to be super crumbled, and nobody can really understand the other people. This is one reason that we just try to limit the amount of broadcast domain. And the next thing is, sometimes we do not really want to have a lot of devices in one network, in one piece of LAN that can talk to each other. We want to limit the amount of devices because they are not all in the same section. Some of them might be in human resources section. They do not really need to talk to people in accounting section. If there is a need, we can of course forward the messages, but as a matter of fact, we prefer not to do that in here. So in this topology that I have here, you can see there are 4 computers. They are connected to 2 different switches, but because all of them are in the same VLAN, they can ping each other. Let's assign an IP address to each one of them based on the subnetting schemes that I have spoken about before. What I'm going to do is to assign an IP address to each one of these PCs. So for this, I'm going to give it an IP for PC4. That's going to be, let's say, 10.1.1.104/24, and that's going to be the only address I'm going to have. I'm not going to set any default router, default gateway. I'm going to copy this. For PC3, that's going to be 103. For PC2, that's going to be 102. And for PC1, that's going to be 101. And as you can see, all of them are in the same subnet, which means that they can and they're able to ping each other. So let's try one of them. I'm going to start pinging 10.1.1.104 from PC1. As you can see, the ping is successful. Now, let's say that the broadcast address for this network is 10.1.1.2.55, and you know why, because this is a 24-bit address. The last octet is going to be the host ID part. This means that if I set all the bits to 1, that's going to be the broadcast address. Everyone is going to hear that. So I'm going to choose to ping 10.1.1.2.55. Now, if broadcast ping is enabled on PC, they can answer to this. Now, you see that broadcast address, of course, is not available on these PCs, but in reality, if someone wants and tries to do that, everybody needs to answer to this, and by answering that, that's going to be a big problem. So this is one of the reasons that security enforces us to remove this kind of thing in our network. Now, what I'm going to do is to make sure that the network is segmented into multiple pieces, and for that we are going to have different VLANs. Let's say, for example, in this example, let's see the topology, PC1 and PC3 are in the same VLAN. This means that PC2 and PC4 are going to be in another VLAN, and without having inter-VLAN routing or any other kind of routing, we cannot really reach to them. And this is going to be what I'm going to do in the next session.